Encore, lesson 80, here we go. What we're talking about is multiplying dimensions. So when I take a shape and I actually make it larger, I can't just double it. So what I need to understand is that if, for example, I were to take a square. Let's pretend that that's square, and that square is 3 by 3. Well, if I look for the area of that, I know that the area equals base times height, which is 3 times 3, so the area of this equals 9 units squared. But what happens if I make a square that's twice as big? I come over here and I say, oh, here's my bigger square. Well, what I'm understanding is my square now, this side wouldn't be 3, it would be twice that. We want it to be 6 units, right? So I'm making this square twice as big as this one. But when I make this twice as big, I need to make the height twice as big as well. That's also going to be 6. So what I find now is my area equals base times height. 6 times 6 is 36 units squared. So when I make it twice as big, something weird happens. I go from 9 units to 36 units. Well, 36 isn't twice as big as 9. What happened? What happened is both of my directions multiplied. So I'm actually, when I make it twice as big, I'm making both sections twice as big. So my whole shape will be 4 times larger, because I have to make this twice as big and this twice as big. That makes this 4 times larger. So let's take a look at 2 of those real quickly. First 2 in your paragraph. Suni drew a parallelogram with an area of 20 inches squared. If she doubles the dimensions, so 20 inches squared, when she doubles the dimensions, what's the area of the new parallelogram? Well, it's not just 40. I have to double it this way and double it this way, which means, just like my square up here, this goes from 3 to 3, or let's actually use a practical application, parallelogram, and we'll say this is 4 and this is 5. That will give me 20 inches squared, right? Well, when I double them, I get that this is 8 and this is 10. So now instead of 20, I've got the area of the new parallelogram is 80 inches squared. In other words, to double it, I have to basically make it 4 times as large of the surface area, because I'm doubling both the width and the height. If that confuses you, it really does help to draw it out like this. So you can say I'm doubling 4 to 8, I'm doubling 5 to 10, and when I multiply it, I understand that both my width and my height have to be doubled in order to get the answer that I need. Abe drew a square with a side length of 20 millimeters. If he draws a new square with dimensions that are half that of the previous square, what's the area of the new square? Well, 20 millimeters, my new square, half of 20 millimeters, and I'm going to go ahead and say half that of the previous square. Half of 20 millimeters is 10 millimeters. So what is the area of my new square? 10 millimeters by 10 millimeters. So area equals base times height, or 10 times 10. So my area is going to be equal to 100 millimeters squared. Okay, so just remember that when you're doubling a shape in size, you're doubling both the width and the height. And we're talking about area, that's a squared unit, which means that it goes 2 dimensions. So if I'm doubling it, I need to go ahead and actually make it 4 times as large. Okay?